All right, so 3-4 is solving exponential and log equations. So the difference is now we're solving. We had a couple of like solving equations in the very beginning when we were first dealing with logs, but the rest of them have been mostly like simplifying this. Now we're going to get to actually solving like an x equals an answer kind of a question. So the first property, which is the one-to-one property, we've done a couple of times. This is just a refresher. So if b to the m equals b to the n, then m equals n, which means if you can rewrite a statement so that the bases are the same, then you can set your exponents equal to each other and then solve for the variable that will be in the exponent. So there's a bunch of different types of problems in this section that are all looped together in the same set of directions for a lot of it. So the hardest part is the approach, like figuring out what to do when you're looking at that problem. If you have a numeric value that is raised to an exponent on either side of the equal sign, then your goal is going to be to get them to be the same base so that you can then solve the exponents. The second kind of problem is going to be dealing with an e to a power. So if I have some sort of equation like e to the x equals a number, then to solve this equation, typically do the opposite or the inverse of what it is to solve it. Like if I was adding 3 to get rid of it, I would subtract the 3. When you're raising to a power, you're taking e and raising to a power, the inverse of the e or the opposite would be to ln that e. So we're almost using ln as a verb here. We're lning or taking the natural log of both sides of the equation. And then from there, you'll be able to solve for the variable. That e has to be isolated first. So the first thing you're going to do is isolate the expression and then take the natural log of both sides of the equation. Simplify using one of the following properties. So you're either going to be doing ln of a base to the exponent, in which you can cancel through the bases and keep the exponent. Or if you have ln of e to the x, same thing here. This can either be moved to the front to give you this statement, or this can be canceled to give you this. Either way, you're dealing with ln and e's, and then you'll solve for the variable. So they will look something like this. If it's a decimal, it'll ask you to like round it to 3 decimal places, okay? But sometimes they're going to be whole numbers. So something like A and D could be on the part of your test that is not calculator based, and then E and C, you'll see, I mean B and C, you'll see that those would be where you'll need a calculator. So because there's a numeric value on either side of my equation raised to a power, what's my goal for A? Good. Get them to be the same base. So what number can I raise to get to 64 and 32? 2. Okay. 4 works for 64 but not 32, right? So I have to break these down. So 32 would be 2 and 16, 2 and 8, 2 and 4, 2 and 2. How many 2's is that? 5, right? 5, 2. So this is 2 to the 5th raised to the x, or to the 2 plus x. And then one more 2 is going to give me 64, which means this is 2 to the 6th raised to the 3x. Everybody with me so far? Yes? Okay, then I got to multiply out my exponents. So this becomes 2 to the 18x, and this becomes 2 to the 5 times 2 and 5 times x. So 10 plus 5x. Now the bases are the same, so I set the exponents equal to each other. 18x equals 10 plus 5x. Subtract 5 from both sides. 13x equals 10. Divide by 13. And x equals 10 over 13. So that's using the one-to-one property if you've got a number with an exponent on either side of the equal sign. Sophia?
Wait, wouldn't it? Oh, wait, never mind.
You good?
Yeah.
Okay, B. Now there's an E involved here, okay? So the only way to get rid of an E is to take the ln of that E. So we're going to ln on both sides of the equation. So I'm going to find ln of e to the x and ln of 4. What happens when you raise ln of e to the x power? So it becomes the exponent. In this case, the exponent is, nope, x, right? So these cancel, and I keep the exponent. I get x equals ln of 4. And then this is where the calculator comes into play. And you want to round to 3 decimal places. So it's 1.386. Okay, C also has an e to the x, but this time e is not alone. So the first thing I do is get it by itself by doing what? Add the 9. So I get e to the x equals 28. And then I need to take ln on both sides. So ln of e to the x equals ln of 28. ln of e to the x cancels, leaving me just the exponent. X equals ln of 28. And I get 3.3322. So 3.332. And with a calculator, these are relatively easy to check, because if I just take that and I plug it back in as the exponent here, you can do e to the 3.332. So if I do that, e to the 3.332, subtract 9 from it, I end up with 18.99, which is not exactly 19, but because we rounded our answer, it's not going to be exact. Okay, so as long as it would round to be the same number, you're good. So easy to check these, especially with your calculators. Okay, and then D. This time, is there an e involved? No. Is there a way to write both of these as the same bases? Yes. What would I change? Good. 1 over 125 becomes 5 to the negative 3. And then the x bases are the same, so I said the exponents equal to each other. 2x equals negative 3, and x equals negative 3 over 2. And again, easy to check. I can plug that back into 5 to the 2x. 2 times negative 3 halves is going to be negative 3, and 5 to the negative 3 is 1 over 125. All right, then you're going to start to see log functions. So you're going to take your log, and there'll be 2 kinds of logs, ones that are logs and ones that are ln's, and change them into exponential notation. So if you have one log, or you only have logs on one side of your equal sign, then you're going to convert your log statement into an exponential statement and solve it. I added this on here because it's super important, okay? Log expressions are only defined for logs of positive real numbers, which means I cannot find log of 0, nor can I find log of a negative number. So all of your log equations must be checked, because you can get an answer like x equals negative 3, but if I were to plug that back in, I get the log of a negative number, which is undefined. So any equation involving a log or an ln, because that is a log, you need to make sure you check your answers and exclude anything that would make it negative or 0. All right, so directions say solve the log equation algebraically and then approximate the result to 3 decimal places. So looking at A, which says log of 5x equals 2. First of all, what's the base on log? 10. So this is really log base 10 of 5x equals 2. And then I want to get it into exponential. So the 10 comes over and picks up the 2, drops off, leaving you with a 5x, and I get 100 equals 5x. Divide by 5, and x equals 20. And then I want to check it. So if I take the 20 and plug it back in here, One, I could check to see if it's right, but two, I'm also checking to see if it's an extraneous root. So if I plug that back in, I get 5 times 20, which is 100, and I can find the log of 100. And it would be 2. So this answer works.
How'd you get 10 squared?
The 10, so I added in the base, which is 10, and then I converted it into exponential notation. So the 10 goes over and picks up the 2, and 10 squared would be that 100. All right, this one says 5 plus 2 ln of x equals 14. So the first thing you have to do, well, not really the first thing, because I can rewrite that as log base e first. But one of the things I have to do is work so that that log is on the side by itself. So how do I do that? Subtract the 5, and I'd get 2 ln of x equals 9. And then I actually have two choices here. What's one way to continue this? Thank you. Okay. Divide by 2. And I get ln of x equals 9 over 2, and then change it to log base e of e. Or log base e of x, sorry, equals 9 over 2. And then what? Okay, get it into exponential notation. So e to the 9 over 2 equals x. Nick. Say again. Because ln is log base e. You've got to get it into that log so that you can then get it into the exponential notation.
If directly from the ln, you just change it to the, like, because what I did was I didn't, instead of changing it to the log base e of x, I just changed it straight to the e of 9 over 2.
So you're just doing that step in the same,
Yeah,
the two steps at once.
Do you need to write?
As long as you've got some work to back what you're doing, you're fine. So this is what I got, and if I take and plug this back in here, I can find the ln of 90. As long as it's a positive number, I'm good. There's like 3 ways to do this equation. Does anybody see a different way to do this one? How about using the properties from here? What happens to that 2 if I were to condense this? Becomes the exponent. So this would be ln of x squared equals 9. You with me so far? That's another way of doing this. So then this becomes log base e of x squared equals 9. E to the 9th. So this comes over, picks it up, would equal x squared. And then I would do e to the 9th, which is 8,103.08. And then when I go to square root it, I would do plus or minus, and I end up with plus and minus 90.017. But it can't be negative, exactly. So if I come up here, the positive works, so I would have kept the positive, but I can't find ln of negative 90, which rules out the negative on this answer, and you end up with the same answer. So you can do it either way. Just make sure you check your answers. So when you say that again?
Doesn't the e pick up the 1?
No, that's if you have ln in your equation and then you get it into exponential. If you have e in your equation, then you're taking the ln on both sides. So ln of e cancels to leave you with the exponent. So x equals 0, yeah. So if you were to catch it from here, right? If it's 1, then the exponent has to be 0. So you could have gotten it that way. Or you could have done what's over here, and ln on both sides of your equation, ln of e to the x cancels, leaving you with just the x. And then ln of 1 is 0, because e raised to the 0 power gives you 1. So either way, you get 0. All right, look at B. So this is actually like a factoring problem hidden, okay? If you have something that's raised to the 2x and something to the x, you can't condense those. There's no way to combine them so they're one thing, which means I actually have to factor this out. So when I put it in parentheses and I take the square root of this, it would be e to the x and e to the x, because e to the x times e to the x gives me e to the 2x. Right?
E to the x squared.
It's not squared. E to the x times e to the x. When you multiply, you do what with those exponents? You add them, so it would be 2x. And then for that second term, I'm looking for the factors of negative 12 that add to negative 1, which are what? Good. Negative 4 and positive 3. And if either of those are 0, then my function is 0, which means set this equal to 0, set this equal to 0. And I'm solving two exponential equations. So on the left, I would add the 4, and I get 4 equals e to the x. And then to get rid of the e, I have to ln both sides.
Pardon the interruption.
So then ln of e to the x cancels, leaving you with just the x, and ln of 4 is 1.386. Let me finish this and I'll go back. And then the other side, I would subtract the 3. And then ln on both sides. I get ln of e to the x equals ln of negative 3. This cancels. And what happens when you type ln of e to the ln negative 3 in the calculator? It should yell at you, right? Because you can't find a log of a negative number. So this one gets ruled out, and this would be your only answer. All right, so what two numbers multiply together to give you negative 8 but add to negative 2? Negative 4, positive 2. So then I'm going to set each of these equal to 0. I get e to the x equals 4, and e to the x equals negative 2. Put ln on either side here, ln on either side here, and I get x equals ln of 4, which we already did up here, 1.386. And then here, ln of negative 2, what's going to happen? Cancels out. You can't find the ln of a negative number. So your only answer is 1.386. All right, so a little bit more with logs. Solve the equation, round to 3 decimal places. Again, I'll let you do A, and then I'll walk you through B. So what can I rewrite ln as? Log e of x would equal negative 3, and then e comes over and picks up the negative 3. And thank you. So it's 0.497, right? So it becomes 0.05. Why?
So you can do the negative 3, but you can't do like ln.
Exactly. So you can't do anything log, ln or log of a negative number, but you can raise a base of a number to any number. So you can raise e to a number, you can raise 2 to a negative, you can raise, like think that e is just really 2.7, right? Okay, so now look at B. So there's multiple logs on one side of this equation. I want to condense it so that there's just one log. So this goes back to your property of logs. If I have just one log on either side of the equal sign, I can use my one-to-one property. So I got to get it down to 1. So if it's addition and I condense it, what is it going to be? Good, multiplication. So this is log base 3 of x times x minus 2 equals log base 3 of x plus 4. As long as the base is the same on the logs on the left and the right-hand side of my equal sign, I use the one-to-one property to set whatever's next to that log, God bless you, equal to each other. So this becomes x times x minus 2 equals x plus 4. Distribute this, and I get x squared minus 2x equals x plus 4. As soon as you see that squared and the x, hopefully it's your hint to get everything to one side because you're going to have to factor this. So I would subtract the x and subtract the 4. And I get x squared minus 3x minus 4 equals 0. Good. Not 3, x minus 4, right? X minus 4, x plus 1. And then each of those equals 0. So x equals 4, and x equals -1. And here's one you have to check because your original equation had a log in it. So if I were to take and plug back in the 4, here it's fine. 4 in here would give me 4 minus 2, which is 2. I can find the log of 2. And then here it's fine. 4 plus 4 is 8. I can find the log of 8. But if I take and plug back in the -1, on the right it's fine. -1 plus 4 is 3. I can still find the log of 3. But as soon as I plug it into either one of these, the middle one I'd get -1 minus 2, which is -3, and I can't find the log of -3. Or the first one, log base 3 of x. If that x is -1, I still can't use it. So I cancel this one out, and x equals 4 is my only answer.
Zeros and negatives, right?
Once you plug them back in, right? So like the actual answer 0 might be okay if the initial log in my equation said like 1 minus x, then it's totally fine.
Okay.
It's when you plug it back in and you simplify what's next to that log, that cannot equal a negative number or 0.
How come you had to like condense it before you were able to like, you know, take it out?
Because the one-to-one property only says that if the bases on either side are the same, then I can get rid of the logs and use what's left. If you just eliminate the logs, you've got an addition problem there instead of a multiplication.
Okay.
And it's wrong. You have to condense it first. All right, so this kind of goes through all of the different steps. Like I said, I think the hardest part of this section is figuring out how to start it. Like looking at it and figuring out what to do from there. So the first thing we went over, if the base is the same. So if it's an e on both sides, or if it's a base of a number like 2 on both sides, or you can rewrite it so that it's the base is the same, then you use the one-to-one property. Same thing for logs. If it's one log on either side, then you use the one-to-one property. If it's an e, so if there's an e somewhere in your equation on the left side or the right-hand side, then you're going to end up taking the ln of both sides of the equation. If there's only one log, then you'll put it into exponential form and solve it. If there's only one ln, same thing, put it into log so that it's log base e, and then put it into exponential and solve it. And then the last one was the one that we just did. If there's multiple logs, you want to condense it, then change it to exponential form if you need to, or use the one-to-one property. So you might be condensing to put it into exponential, or you might be condensing to use the one-to-one property. Either way, if there's multiple logs on one side of the equation, you're going to condense them.